Solving quadratics. So in class we did a lot of factoring. There's a reason for that because it's a necessary skill to have if you plan on solving quadratic equations. So as we review, quadratic equations are basically equations where they have a power of 2. Okay, so we have x squareds here. And solutions to quadratic equations, you may also see these called zeros. You may see them be called roots, and you may see them called x-intercepts. Okay, all that basically means solve for x. Figure out what x is going to be so that the equation works. That's what that means. Okay, so don't get thrown off by those words, just solve for x. Okay, so we're going to start with some easy quadratic equations, solving for x. So in number 1, we have x squared equals 16. Now if we have x squared, how would you undo x squared when you solve an equation? You're going to take the square root of both sides. Okay, so if we take the square root of x squared, that's just going to give us x. What's the square root of 16? That'll give us 4. So we have x equals 4. And there's another solution. What do you think the other solution is for x? X can also be negative 4. Because remember, when you square a negative number, when you do negative 4 times negative 4, that's going to give you positive 16. So you actually are going to have two solutions for x in these because, well, there's a power of 2. So you could have two solutions for all of these. And our two solutions are negative 4 and 4. So x can be negative 4 or x could be 4, and that equation will work. All right, so keep that in mind. You are going to get two solutions for all these. Let's do number 2. 3x squared equals 27. What do you think we do first to solve this equation? I'm going to divide both sides by 3. Okay. The reason why is I'm working backwards through the order of operations. So if I knew what x was, I would square it, then multiply by 3. Well, now I'm going to work backwards. I'm going to undo multiplying by 3 by dividing by 3. And now 27 divided by 3 is 9. And now I'm going to take the square root of both sides. What's the square root of 9? That's going to give me 3, or remember, it could give me negative 3. Okay, so my two solutions are negative 3 and 3. If I plug in negative 3 there, it'll work. Negative 3 squared is 9, because negative times a negative is positive, and then 3 times 9 is 27. Or I could plug in negative or positive 3, and it'll work. All right, number 3. What's the first thing I'm going to do in number 3? I'm going to divide both sides by 9. And now if you do 64 divided by 9, you're going to get a decimal. Just leave it as a fraction, and you'll see why. Now how do I get rid of the x squared? I'm going to take the square root of both sides, and what I'm going to do is I'm going to take the square root of 64, and I'm going to take the square root of 9. What's the square root of 64, and what's the square root of 9? Square root of 64 is 8, square root of 9 is 3, so it's just 8 divided by 3. But remember, it could also be negative, because when you square a negative, that still gives you a positive. So my two solutions are negative 8 over 3 and 8 over 3. All right, and then this last one, what do you think we would do first to solve this equation? I'm going to add 144 to both sides, because remember when we were solving equations, you do the addition and subtraction first, and then deal with the multiplication or division. So I'm going to add 144 to both sides to get that negative 144 on the other side. Negative 144 plus 144 will cancel. 0 plus 144, whoops, gives us positive 144. Then I'm going to divide both sides by 4. Okay, 4 over 4 will cancel and give us 1. 144 divided by 4 will give us 36. And then what would x have to be so that x squared gives us 36? Could be 6, or remember, negative 6. So my two solutions are negative 6 or 6. So those are all pretty straightforward. That's just solving equations the way you know how to solve equations. It's just that last step you'd have to take the square root to get your solutions. But what if we have something like x squared plus x minus 20 equals 0? Your idea is to try and get everything away from the x, but you have an x squared and an x here, and it just gets really complicated. So we're going to talk about how you'd handle a situation like that. First, let's explore this property right here. If you have two numbers and you multiply them and the answer is 0, what do you know about those numbers? That if you multiply them and you get an answer of 0, what has to be true about the numbers? One of them has to be 0. So x could be 0 and then y could pretty much be whatever it wants. Or x could be whatever it wants, but y has to be 0. Or they could both be 0. Okay, but the bottom line is when you multiply two numbers and get 0 as an answer, one of the numbers must be 0. And that's the zero product property. If the product of two numbers is 0, then one of the two numbers must be 0. Now, knowing that, okay, when we have this type of situation here where it's not as easy as these ones up here, we are actually going to solve these equations by factoring. And that's why we spent the whole day on factoring. Okay. So we're going to actually factor them and then solve them. Now these first few, I'm going to show you what happens. These are already factored for us. So I'm going to show you what happens after we get them factored. After you have your two factors, we're going to use the zero product property. And if we have x plus 2 times x minus 3 and they somehow multiply to give us 0, I know one of them's got to be 0. So I'm going to set each of those equal to 0. I'm going to set x plus 2 equal to 0 and x minus 3 equal to 0. And now I'm just solving two equations. Okay. To solve this one, for x, I would subtract 2 from both sides. X is negative 2. How would I solve this equation over here? I'm going to add 3 to both sides, so x is 3. And those are actually my two solutions, negative 2 and 3. Okay, so you factor them and you get two factors, and then you set each of those factors equal to 0, and you'll get your two answers. So let's try this one. I'm going to set 2x plus 3 or minus 3 equal to 0, and x plus 4 equal to 0. Let's just focus on this first equation. What would I do first to solve this equation? I'm going to add 3 to both sides, so that gives me 2x equals 3. Then what? I'm going to divide both sides by 2. So x equals 3 divided by 2. And just leave it as a fraction. And now over here, how would I solve this equation? I'm going to subtract 4 from both sides. So x is negative 4. So my two solutions are negative 4 and 3 over 2. And I'm just writing these in order from least to greatest when I write the solutions. And keep in mind they must be in curly brackets, because if you do parentheses, that's going to be an ordered pair, and that's not what we want. We just want to say that these two numbers will work. So they need to be in curly brackets to show that they're both solutions, kind of like listing the domain and range. Okay. If you put parentheses, I'm going to think it's an ordered pair, and it's going to be marked wrong. So make sure you're doing curly brackets. All right, the last one. Okay. We have x and x plus 7. So my first factor is x equals 0, and that one's actually solved because x is 0. The second one, x plus 7 equals 0, what would x have to be? X would be negative 7, so my two solutions are negative 7 and 0. Alright, so your turn. Find the zeros. So split these into two different equations and solve for x. Alright, now example 2. These aren't factored. Okay, so we are going to have to factor them first and then solve the way we did up here in example 1. So let's factor x squared plus x minus 20. Okay, ignore the equals 0 for a second. What are two numbers we can multiply to get negative 20, but add to get 1? That would be positive 5 and negative 4. Okay, so you have x minus 4 and x plus 5. And now we can do what we did up here. Set x minus 4 equal to 0, and set x plus 5 equal to 0. So what's the first x value here? That's going to be 4, and what's the x value over here? Negative 5. So my two solutions are negative 5 and 4. Same with E. Now this looks like it's going to be pretty complicated. Is there a GCF that we can have here that we can divide both of those by and take care of it? GCF of 5. And now what I have here is a difference of squares. Remember the difference of squares? What's the square root of 16? That's going to be 4. So remember, I still have the 5 out front, but then I have x plus 4 and x minus 4. I need a plus and a minus. Okay? And now I have 3 things here that I'm going to set equal to 0. The first one is 5. Now, does 5 equal 0? No, it doesn't equal 0. So we're actually going to ignore that. We call that an extraneous solution. You're not going to see that very much in Algebra 1, but it is a possibility. So you just kind of you just ignore that. Just focus on these two. The x plus 4 equals 0 and the x minus 4 equals 0. Let's focus on this first one. What would x have to be in this equation? Negative 4. And how about this one? Positive 4. So my two solutions, I'm ignoring the 5, and I'm just going to have negative 4 and positive 4 be my solutions. So that was kind of a weird one, but really you just ignore the 5, and then you do everything like you've normally done. And then F. Go ahead and factor x squared plus 2x minus 24. Two numbers you can multiply to get negative 24 and add to get 2. You should have positive 6 and negative 4. Okay. And now let's set up both equal to 0. X plus 6 equals 0, x minus 4 equals 0. What's x going to be here? Negative 6. What's x over here? It's going to be 4. So my two solutions are negative 6 and 4. And remember curly brackets because it's a set of numbers. So on the next page, go ahead and do the your turns. All right, the last thing, okay, this really isn't that bad, but sometimes, you notice how all these equations were equals 0 or equals y, but we just we put 0 there in its place. Some of them won't equal 0, okay? It's fine, we can just do some simple algebra to fix that. And then, once it equals 0, we can go ahead and find the roots. So in this first one, x squared plus 2x equals 15. See how it doesn't equal 0? I want it to equal 0. So I'm actually going to subtract 15 from both sides. And what happens is 15 minus 15, that gives me 0. On the other side, though, there's nothing I can combine the 15 with, so I just kind of tack it on at the end. So now it equals 0. Now I can do what I've been doing. Okay. Factor x squared plus 2x minus 15 for me. That's x plus 5x minus 3. Set up your two equations. What are my 2x values? X would be negative 5. X is 3. So you get negative 5 and 3. In H, x squared plus 6x equals negative 7. Now, I don't want that negative 7x. I want it to equal 0. So to undo negative 7x, I'm going to add 7x to both sides. And when I write it over here, it'll equal 0, and that's what I want. I want those to cancel out and just get 0. Over here, I can't combine it with the x squared, and I can't combine it with the 6. And you notice how x is always the second term? I'm going to write this out so that that 7x just kind of slides in between the x squared and the 6. Now factor it. We have x plus 6, x plus 1 are our two factors. So set them each equal to 0. What are our two solutions? Negative 6 and negative 1. So your two solutions are negative 6 and negative 1. And then the last one, x squared equals 3x minus 27. So it doesn't equal 0 here. What I'm actually going to do is subtract. I'm going to bring the 3x and the 27 over to the other side. I could bring the x over, but then it would be a negative x, and that just makes things, the negative x squared here, that's just going to make things complicated. So I'm going to bring the 3x over and the 27 over. And they are opposite sides. So what that's going to give me is x squared. Now it's minus 3x and minus 27. But it equals 0. And that's what I want. Now let's factor this. What do you get when you factor it? X minus 9 and x plus 3. And then x minus 9 equals 0, x plus 3 equals 0. What are my two x values? 9 and negative 3. So negative 3 and 9 would be my two solutions. So your turn, find the roots. They don't equal 0, but you can just move some things around to get them to equal 0. And then factor and find your roots.